Hello everybody! In this video, I'm going to show you how to solve number 15 of the AMC 10B 2019. The problem asks, the base 10 representation for 19 factorial is 121-6T5-100-40M-832H00, where T, M, and H denote digits that are not given. What is T plus M plus H? We're given 5 answer choices, 3, 8, 12, 14, and 17. The first thing that we can note is that 19 factorial has to be divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, all the way up to 19. This means that this number right here, which is 19 factorial, is divisible by all of those. This means that we can simply just test divisibility by each, and then we can find T plus M plus H. The first divisibility rule that we realize we can test is divisibility by 9, because of course we have to find T plus M plus H, so it seems like a good idea to start with divisibility by 9, since divisibility by 9 involves just summing up the digits of 19 factorial, so then we might be able to find what T plus M plus H is. So the first thing, we sum up all these digits, so 1 plus 2 plus 1 plus 6, ... And this ends up equaling 33 plus T plus M plus H. And this number must be divisible by 9 in order for divisibility by 9 to work. So that means that this has to be equal to either 36, 45, or 54, and so on. But the thing is that T, M, and H can only be up to 9. So the max value of T plus M plus H is 27. So 27 plus 33 is equal to 60. So the max value of this right here is just 60. This means that 33 plus T plus M plus H can only be one of these 3. But still, it's 3 choices, so we don't know which one it is. The first one, we have case 1, T plus M plus H is 3. T plus M plus H could also be 45 minus 33, which is 12. And lastly, T plus M plus H could also be 21, which is 54 minus 33. We see that we can immediately cross out this possibility because if we look up at our answers, 21 is not there to be seen. We're only left with 2 choices, 3 and 12. This means that we'll have to find divisibility by another number in order to find what T plus M plus H is. Another good divisibility check is with 11, which is alternating sums and differences. So we have 1 minus 2 plus 1 minus 6 plus T minus 5 plus 1 minus 0 plus 0 minus 4, and so on. Evaluating this alternating sums and differences leaves us with T minus M minus H minus 7 equals 0. So now we have 2 equations, kind of, and we can use this to narrow down the possibilities, these 2 possibilities, and finally find our answer. First, let's try T plus M plus H equals 3. So we can add these 2 equations together, T plus M plus H plus 0 equals 3. This gives us 2T minus 7 equals 3. And solving for T, we have 2T equals 10, and we're left with T equals 5. But if T equals 5, then T plus M plus H, and T plus M plus H equals 3, then M plus H is negative 2, which is impossible because T, M, and H are all positive. Therefore, we have a contradiction, and t plus m plus h equals 3 is not possible. Therefore, our only solution is t plus m plus h equals 12, which means our solution is just C. Thanks for watching. I hope you enjoyed. I have other videos on AMC 10B 2019, so be sure to check those out soon. Thanks for watching.